All right, here for week two video lesson of remote learning for geology. What we're going to look at is a review of Chapter 7. Chapter 7, we dealt with plate tectonics and looked at some of the underlying theories that make up the broad idea of plate tectonics. So we want to look at, what is some of the evidence to support this plate tectonics theory. Want to look at the two main ideas that get brought up, and that's continental drift hypothesis and the seafloor spreading. And then we'll look at differences among the plate boundaries themselves, the three major plate boundaries, depending on how they're moving. One of the other things look at right at the end is what is the mechanism for how all this stuff actually works? I mean, how is it all moving? So start off with Albert Wegener, which was a German meteorologist who first comes up with the idea of continental drift. Basically saying that the continents are free to move and that at one time they were together like pieces of a puzzle. And if you look at the general outline of the continents themselves, they all kind of look like they match up, especially South America and Africa. It looks like they kind of squeeze right together. He called that, if you put them all together, he called that Pangea, which was the first major continent that we would have all of them land masses put together. Picture of Pangea and what it looked like about 200 million years ago, and it's since broke apart into what we have today. He used some other evidence to support this hypothesis. He just didn't use the fact that they fit together like pieces of a puzzle. He looked at how the fossils match up across the ocean, how the rock types and structures, the layers of rock, tend to line up across from each other, like, again, South America, Africa, North America with Europe. And you see that there are many different evidence to help support this hypothesis, not just the fact that they fit together. One of the main objections to Wegener's proposal, though, was he really didn't say why it was happening. Okay, yeah, all this stuff looks like it could be. What's causing these massive mountains and continents to be able to move on the crust? He didn't think there was a mechanism or a force. People didn't think there was a mechanism or a force that was large enough to be able to move those things. And on top of that, he's a meteorologist, so he's doing something that's outside of his field, and not having that mechanism or driving force to cause the continents to move kind of told people that, or didn't allow people to believe him at that time. Well, when you look at the plates themselves, if we call they're lithospheric plates, which is a large chunk of Earth's rigid outer shell. That's what the lithosphere is called, and breaks off into these plates. Many of them very large, some of them, little tiny ones. The largest one's the Pacific plate, basically the whole Pacific Ocean. And they are the continents themselves, but also you have plates that are underneath the ocean. Brings us to three different types of plate boundaries. Boundaries is where two different plates are going to interact. Call divergent plate boundaries basically when the plates are going to slide past each other. We call that a constructive margin, in the fact that it's building new ocean floor as it does it. It's places where the mantle moves up. We have places that we always want to be able to describe what they are. We look at the mid-ocean ridge or rift valleys as being places where divergent plate boundaries are taking place. So we do have them on the continents. That's the Great Rift Valley in Africa. We also have the mid-ocean ridge, which is right in between the Atlantic, in between South America and Africa. You have convergent plate boundaries, which said that are coming together. These are going to be destructive forces. They're destroying continental or parts of the crust. These are plates where they collide, and you have three different types of convergent plate boundaries, because you have two different types of plates, one of them being oceanic, the other being continental.